is a NiCad battery which has a screw retained base. This Makita battery has a factory sealed case. The factory sealed cases are glued together. This Makita battery has a screw retained case. In this video we show how to repack the battery and try to avoid breaking terminals like this. This connection is terminal. Here the glued case is placed in a large vise. A piece of wood is used to gently coax the joints. Sometimes the vise is tightened to crack the joints as well. As you can see, the screw retained cases would be a lot easier to open. Once the glue joints are broken, the halves can be separated. Here I am using the vise to break the final joins. The cracking noises are the glue or the actual plastic. Some packs need gentle coaxing with a rubber hammer. This case will be discarded. We will be repacking and using a screw retained case. We want the terminals out of this battery pack. The upper section batteries were joined to the lower bank. Try to remember where the components go back into place. For example, this heat sensor sits into this area, just down in between there. This positive terminal joins to this negative terminal. And same here. So just remember where all the terminals go. I use a long nail to push the upper cells out. This reveals the upper cells with the terminals we want to keep. These are very strong spot welds. If we pry these welds, the terminals will break. We're going to carefully drill through the spot welds. Use a sharp drill bit about the diameter of the weld. When drilling, be careful not to drill right through the cell. If you go right through the cell, it does not matter too much. We are not going to keep the cells. We mainly want the undistorted terminals. The welds are all cut through. You can see the cell where I went right through. You can see the finger where I went right through as well. One cell has a heat switch attached. We peel back the tape to see where it joins. Use pliers to pull off the spot welded tab. We now have the terminal we need. We have not broken the weak plastics. I use a small wire wheel to clean off corrosion. NiCads and nickel metal hydride batteries tend to leak a lot. We clean these terminals as well. The corrosion can keep creeping if you don't clean it all off. How do we join to this terminal with the holes in it now? I use a battery spot welder to join new tabs. Do not try soldering the tabs on. We also do not want to solder onto the new cells. Spot welding is neat and the joint is reliable. Once the extra tab is attached, we can trim it back. The added tab will be used to weld onto the cell. Here I have good cells from a used medical device. The cells are joined together. Remember that the whole side of the cell is negative if the green coating is taken off. When two joined cells are separated, the negative side is exposed. You will see later why we need to insulate the side immediately. The spot welder is used to attach the new tab to the top cells. I use this blue vinyl to insulate the exposed side of the cell. The vinyl can be custom cut to match the size of the cell. It also is inexpensive and leaves no sticky residue. It can also be shaped with a heat gun to wrap around the cell. This shows the neat join onto the top cells. The original battery pack pattern is used to align the new pack. I use strips of tape to insulate the new joining tabs. The tape is to insulate the tab from shorting. If any part of the battery shorts, the energy dissipation is immense. We only want the tabs to touch on the cell tips. If the edge of the cell shorts with the center, you will know about it. We get our insulated tabs ready. Here we have not wrapped every cell that has the negative side exposed. If any side shorts to any cell, there will be a huge power dissipation. The power is so immense it can burn through the new tabs. Just like that. We now make new tabs using glass cloth insulation tape. The fire was not the faulty black insulation. Let's go back to the previous video. You can see where the body of the cell short. See that red mark there? You can see here, and then this creates so much current draw that the tab glows red hot and the fire starts. This is why we need to insulate each cell body. To join the upper to the lower cells, we do not want to use wire, we weld tabs. Separate pieces are joined to change directions. This shows that the wire is too thick to close the halves together. The wire prevents the halves closing up. With welded tabs, the halves sit neatly together. With all spot welded joins, we can now close up our battery pack. We repacked with nickel metal hydride cells because they were available. We get to use the original charger as well. Repacking with lithium ion cells is possible, but the charger setup has to be different. The drills live on. Thanks for watching.